Welcome, boys and girls. Gonna be a quick video this afternoon because this principle is one of those geometry things that you're like, yeah, well, duh, this is true, of course. So let's go over it really quick. So Cavalieri, you can say, because that's easy, but it's actually Cavalieri. He has a principle, my guy. He's just cool, okay? If in two solids of equal altitude, so equal height, okay, the sections made by planes parallel to and at the same distance from their respective bases are always equal. I'll get into it in a second, don't worry. Then the volumes of the two solids are equal. This also can work for area. Say what? Okay, take a look at the figure here, or the two figures here. So I've got two triangular prisms, right? One looks erect, height normal, like you would normally see if it was a triangular prism standing up. This one, however, is like the Leaning Tower of Pisa, right? It's just leaning over a little bit. What this principle says, that the two figures are equal in height or altitude, which you can see here, both triangular prisms, although this one is slanted, they both have the same height. The two figures have equal cross-sectional areas. Think about these parallel planes. There's three of them here. What it means by cross-sectional area is the pink sections. Because the parallel planes set up both figures with equal areas.
Any students remaining in the building, please come to the front. Any students
the two
remaining
figures
in the building, please come to the front office.
will have the same volume.
Go Lions.
Okay, so let's go that again. Equal heights, equal cross-sectional areas, same volume. Okay, now again, one of those geometry principles that are like, well, of course they are, because that just makes sense. Okay, another picture here for you. This one is, so they use coins a lot, and we'll use coins in class when we talk about it. But if I have a pyramid based on, looks like cake, right? And then this one's just kind of shifted over a little bit. Again, if they have the same altitude, which they both do, okay? If they have cross-sectional equal areas, which again, they do. So let's take the second one, for example. That second cylinder area looks like the same as that one. Then they will have the same volume, which they do. Now, the conditions, obviously, we need for a conclusion, which are really just fun facts of geometry. Conditions, two parallel planes. There certainly can be more, but we need two at least. Two solids between the parallel planes, so two three-dimensional figures, and in some cases the area, but we're really talking about volume right now. And then every additional plane parallel to P and Q, which again would be that third or fourth or fifth or infinite plane, okay, must cut equal areas on both figures, parallel to the figures. So for example, I can't take P, that's up here in parallel, and Q down here, and I can't mix and match. I can't have a P and a Q. They've got to be P, then P, Q, then Q, okay? The conclusion to these three conditions is the volumes of the two solids are equal. Now, one of your quiz questions, it says something about a cylinder and then a rectangular prism. I believe that one of the answer choices is a little off. Now, take a look at it. It says something about the base area. Now, the base area is a circle on one, obviously, and on the rectangular prism, it's a square or a rectangle. Depends on what it looks like, I forget. Be really careful. There is no indication whatsoever that those areas are the same. Nothing. So you want to select that as your answer choice. Let me know if it becomes an issue on Remind, and then I'll go ahead and fix it. I just don't remember what I put. All right? Have a great time. See you tomorrow. Pretest. Booyah. 4 minutes. Well, not really, but close. Bye-bye.